All right, let's get into our second one. And probably should have started with this, but whatever. Maybe caught your attention, freaked you out a little bit on the first one, where I didn't do the best of jobs of explaining, but I have no time. Gotta get these videos made for y'all. All right. Here we go. Here's just a graph showing us the area. So there's some velocity function that's given. Here it is. There's your velocity function. And let's say that we want to know the distance traveled. From t equals 0 to t equals 8. And we want to know the displacement from t equals 0 to t equals 8. All right, so anything that is below the x-axis, or the t-axis in this case, is going to be a negative area. That would be a negative displacement. So if we were to talk about this for displacement, I'm not going to use any units on this one. We would say that it is negative 20 plus 14 minus 10 plus 6, right? Because everything down here, this is negative. Oop, I say negative, right? Positive. Come on, man. Be better. You know, that's negative. That's negative. Up here, this is positive, and this is positive. So we put it all together, and now my biggest freak out here is like, oh crap. Do I know how to math? And we get negative 10. But if we were to go look at what was the distance traveled, well, we take the absolute value of negative 20 plus the absolute value of 14, not needed, plus the absolute value of negative 10 plus the absolute value of 6. So this is 20 plus 14 plus 10 plus 6. So what is that? 34, 44. This is 50 units. So there was a lot of distance traveled, but not a lot of the displacement. It didn't go very far from the original position. So this is the game. So we actually have to know where there's intercepts. So let's try a pretty straightforward one, I believe. So let's just find, I know this is distance traveled and displacement. Let's just find the distance traveled. So we have some velocity function, which is equal to 6 minus 2t. Now I'm going to graph it, but when you get good at it, like I know when I was a student, I didn't graph these, I just knew. Set the function equal to 0 and figure out where the heck the intercepts are. So we have 6 minus 2t, which means it's going to start up at 6, and then it's going to travel down like this in a straight line to wherever it is for 6. How did I know that it started at 6? You ever seen something like this? Y equals negative 2x plus 6. Sorry, I changed the v of t to y. I changed the t to x and put it in there, saying that the y-intercept is 6, and we got a slope of negative 2. So we need to know, where does it cross over? Where is this crossover? Well, you set it equal to 0, and you solve. So you get 2t is equal to 6, and t is equal to 3. Oh, goodness. How convenient. So that means we have some negative area down here. We got some positive area up here. And I'm pretty gosh darn certain those are the same freaking triangles. But I'm not going to do this through geometry. I think I'll just do this problem regularly. So to get our displacement, which we could do, it would just be the integral from 0 to 6 of r 6 minus 2t dt. That would be the displacement. Displacement's simple. You just run it right through, take some antiderivatives, go, you'll get it. No big deal. But what about the distance? Well, the distance would have to be from 0 to 3 of 6 minus 2t, use an absolute value. I'm not going to use an absolute value in a second, but I'm just showing it. And then we're going to go from 3 to 6 of the absolute value of 6 minus 2t dt. The way I'm writing this is silly. This is terrible. This is bad. This is bad. I don't like it. But knowing what the graph looks like helps. I know that this is negative. But so that means we're going from 0 to 3 of 6 minus 2t dt. Now we know that this answer is negative. So you could just change this sign to a minus sign and go from 3 to 6 of 6 minus 2t dt. That would change everything. That would take our positive thing and change it to a negative thing. Or if you're like, I don't like that, we could have said, all right, we'll leave this thing positive and make this a negative. So let's run through it. I would definitely want to do this by geometry typically. So maybe we look at it like this. And we leave the plus sign. Well, let's distribute that negative in, and now we can say it's 2t minus 6 dt. Now let's finish up the problem. See how tedious these problems are? So the antiderivative of 6 is 6t. The antiderivative of 2t is, or negative 2t is negative t squared, evaluated from 0 to 3. Now we're going to add it 2. Now we're going to have t squared minus 6t for this part, evaluated from 3 to 6. Let's get it. So we have 6 times 3 minus 3 squared minus 0. 0's the best. So there was our first part, okay? That was our first one. Now we're going to add it to our next piece. So now we're going to get 6 squared, our upper bound, minus 6 times 6. And now we have to subtract out 3 squared minus 6 times 3. All right, let's go get it. Let's see what we're going to end up with. So this is going to become 18 minus 9 plus, and now we have 36 minus 36, 0. That's convenient. Minus the quantity of 9 minus 18. So this is just going to become positive 9. Sweet, we did it right. If this ended up being negative, you just change its sign. And we have 9 plus 9, which is equal to 18. I don't know what the units are. It doesn't tell us. So the answer is 18 units. But we could see, since we got the same numbers here with the displacement, we would have ended up with 0 again. Also, by just looking at this piece of, oh, sorry about that. Old people and their technology, you know what I mean? We can see that there is symmetry about this. That, of course, the areas should cancel out. But we ended up with the same area up top as we did down below, if you take the absolute value of it, of course. And there it is. I hope that made some sense to y'all. I hope. It was a little tricky. All right, that's what we have. We have classes, too, so we can talk about this and you can ask questions. So, all right, we'll probably just make one more for this section and we will move on. See you.